In today's video, we are going to be dilating segments and angles, giving a certain amount of information and maybe given some diagrams, maybe given some problems without diagrams, but just knowing our vocabulary and being able to decipher the information. So in this one, they do give us a diagram to help us. So it gives us the segment FG, and this is 12, and it's saying it's being dilated by a scale factor of 3/4 to form F prime G prime. So in order, again, when you dilate by a scale factor, you have to multiply 12 times 3/4. So what I'm going to do is real quick calculation, 12 times 3/4, right? You can use a calculator to help you. 12 times 3 divided by 4 is 9. So that means when I dilate it, it's going to be 9. And let's put that in. Submit. Boom. Okay, let's look at another one. And even gives us a little diagram there. Okay. Let's do this one. Okay. The segment below is S prime T prime after a dilation of a scale factor of 1/2. What is the measure of ST original? So this is after it's dilated. Okay. So after it's dilated, again, what do I do to figure out the original figure? So this when it's 1/2, it becomes smaller. So there's two ways you could do this. You could take 18. Oh, I need a pen. 18 and divide it by 1/2, or 18 multiplied by 2/1, keep change flip, or just do 18 times 2, which is both the same thing. It is 36. Okay, so 36, when I take a half of 36, it's going to shrink it down to 18. So let's do that. Bam. Look at that. Gives us a little diagram, shrinks it. And they might do it a different way than I explain it, but I kind of try to make it the same consistently. All right, maybe let's do one more with a diagram. Let's do. Okay, this one's pretty simple, right? QR is 3. Okay, it's dilated by a scale factor of 5. So you just do 3 times 5, right? 3 times 5, which is 15. Boom. Okay, I mean, that one's simple. I'll show it bigger. I wanted to make sure I covered one that got bigger. Okay. Sometimes they might not give us a diagram. Okay. So let's look at one where they don't give us a diagram. All right. So it's dilated by a. I don't want to do this one. We'll do. Okay. All right. I don't like how they're the same number. Okay, this one. LM is dilated by a scale factor of 1/3 to 4L prime M prime. The original, without the primes, is 21. So when I multiply that by the scale factor, so 21 times 1/3, which is 7, that is going to be the length of it after it is transformed. So I'm going to put in 7. Okay, so you got to be careful what you're looking for. It's looking for the measure after it's transformed. Okay, and if it's the one after it's transformed, you have to multiply the scale factor by the length. If it's not, which we'll look at again here, if it's not like this one, I'm going to erase this. Clear screen. Come on. All right. KL is being dilated by a scale factor of 3/4. This one's after it's dilated. So again, you do 3/4 and you divide it by the scale factor after it's transformed, which is the same thing as multiplying it by the reciprocal. 3 times 4/3 is actually, I just canceled these out, it is 4. So 4, when you multiply that by 3/4, it ends up becoming 3. So when, again, we're looking for the original, this was when we have to divide or multiply by the reciprocal. Okay, so this should be 4. Bada boom, bam. Let's do one more. Clear this stuff. Clear this stuff. Okay, here we go. This is dilated by a scale factor of 5, and the transformed figure is 15. I want to find the original. Again, so if I have to find the original, I have to divide them. So 15 divided by 5, all right, which is, I don't know why did I write 3? I meant to write 5. So 15, I'm going to write it like this, divided by 5, right? That is 3. I was getting ahead of myself. So the scale factor is 3. 5 times 3 is 15 after you transform it. So the scale factor, oh, no, I'm sorry, the measure PQ is 3. And it should give a diagram, right? It does. Yeah, it gives a diagram. It gets bigger, boom, and shows how it gets enlarged by the scale factor. Now, so that's when you dilate a segment. Now, an angle is even easier than a segment, to let you know. All right, so an angle, if you dilate this, it doesn't matter what the scale factor is. It's going to stay the same. All right, so it doesn't matter. It's just the same exact angle. And I'll show you. Boom, it still stays 136. All right, let's look at another one. 25, it's going to stay 25. So when it's similar, the angle size stays the same. All right, it doesn't change. Okay, just the side length. Let's do one more. And again, 144, going to stay the same, even if there's no diagram. Okay, even if there's no diagram. Let's look, no diagram. Stays 145. Doesn't matter what you multiply it by, it's going to stay 145. And one more, same thing, 122, 122. So the angle measure stays the same, just not the side length. Those you have to multiply or divide by the scale factor depending on the scenario. So that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.